Now, the direction field shown below corresponds to which differential equation? Well, let's think about it for a second. We're looking at this, and we're thinking that when we are at 0, the slope is 0. So if we get the cosine, so it's definitely not this one, because the cosine of 0 is 1, and here we have a slope of 0. Now, the sine of 0 should be 0, so this could be a candidate, and the other three could all be a candidate. Now, when we are at 0, the slope is 0. You see how it's 0? But we are at 0. The y is also 0. See, I would have a little bit of trouble figuring this one out. Let's see. So let's just plug in some values and see. This is -2 comma -2. If I put -2 here, I get -8. But I don't get -8, so that could be true. Let's see this one. If I put -2, -2, I get -2 times -2 squared, which is equal to -8. This one could also be true. If I put -2 in here, I get sine of 4. And sine of 4 is, if I do 2 pi divided by 4 divided by 2 pi. I will get 0.6. So it's more than half, so it's going to be a negative y, but very small value. So I think we could get rid of this one. Now let's see. This one says it's only dependent on the y. This one's only dependent on y, which would mean that as we move along this way, we should all have the same values. But we see that we don't, so we can take that one out. So we're left with this one. But I want to double check again if there's a better way for the sine of xy. So the sine of xy, let's say we put 0, 0, the sine of 0 would be 0, so that works. Well, let's say we put 1, well, let's say we put 2 and pi. So 2 for x would be here, pi for y would be 3.14, so it would be right here. But 2 pi should be 0. So we can cancel this one out now to be super sure, because the sine of 2 pi is 0. And here it gives us an output that is super, super steep. Okay? So that's our answer.